Hello guys, welcome to my channel. Myself Akshaya, and today we are going to discuss about partial derivatives and its application in economics. Before describing partial derivative, let us see what is a function. So, a function shows the relationship between the independent variable and dependent variable. In simple terms, it expresses how one variable depends on another. But in real life situation, we can see that functions with more than one independent variable. Such a function is called multivariate function. For example, fxy is a function with two independent variables x and y. Now we get a general idea about function and multivariate function. So let us move to partial derivative. Partial derivative means if a function has more than one independent variable like z is equal to f of xy, then partial derivative tells us how z changes when one variable changes while keeping the other constant. For example, consider a function z is equal to f of xy is equal to 4x square plus xy plus 3y square. Now, if we partially differentiate the function z with respect to x, then we need to keep y constant. Remember that the usual rule of differentiation like sum and difference rule, product and quotient rule, and the composite function rule, etc. hold in the case of partial differentiation also. Now back to the example, we can partially differentiate z with respect to x. Again, remember that the derivative of constant is 0. So, while partially differentiating z with respect to x, we get 8x plus y. Similarly, now partially differentiate z with respect to y. Here we get x plus 6y. This type of partial derivation is called first order partial derivation. Partial derivatives are denoted by the symbol that shown in these equations. We can call this as partial derivative of of f with respect to x or y. The symbol of small d is not used here because it only used for total change in single variable function. Now the next topic is second order partial derivative. In order to explain second order partial derivation, let us consider the function z is equal to f of xy. The function can yield two first order partial derivatives, that is f of x is equal to partial derivative with respect to x and f of y is equal to partial derivative with respect to y. The first order partial derivative are themselves function of x and y, that is fx is equal to g of x y and fy is equal to h of x y. Now the functions g and h can themselves be partially differentiated with respect to x and y. That is, fx is itself a partial derivative and can be partially differentiated with respect to x and y. The same true for fy too. So, if we do partial derivation to first order partial derivative, it's called second order partial derivation. if we do first order partial derivative to understand how much does output change when one input changes, then we need to do second order derivative to understand how that effect get stronger or weaker as you keep changing it. So when we do second order derivation, then it will become as second partial derivation of f with respect to x or y. Next is cross partial derivatives. Here the order of differentiation is from right to left. That is, fxy means partial derivative of z with respect to y and then with respect to x. Similarly, fyx means first differentiate z with respect to x and then with respect to y. Now, according to Young's theorem, the order of cross partial derivative doesn't matter. That is, it doesn't matter whether a function is first differentiated with respect to x and again differentiated with respect to y or vice versa. We have discussed the basics of partial derivative, and now let's move to its economic applications. So, in economic, partial derivative in economics is mainly used in partial elasticities, production function and in utility function. First, let us see how it used in partial elasticities. Here, x1 and y1 are two demand function of two goods and P1 and P2 are their prices. Now to find partial elasticity of demand for x1 with respect to P1, we partially differentiate x1 with respect to P1 and multiply it with the ratio of P1 and x1. Similarly, to find partial elasticity of demand of x1 with respect to P2, we partially differentiate x1 with respect to P2 and multiply it with ratio of P2 and x2. Here, partial elasticity of demand of x1 with respect to P1 is direct partial elasticity of demand, and the second one, partial elasticity of demand of x1 with respect to P2, is cross partial elasticity of demand. Next is production function. A production function represents total product. Therefore, marginal product will be the first partial derivative of total product with respect to one of the factor while keeping other factors constant. For example, marginal product of labor is the first partial derivative of total product with respect to labor while keeping capital constant. Euler's theorem can be stated in the terms of partial derivatives. If P is equal to f of L k is the production function of two factors labor L and capital K, then the Euler's theorem states that L into marginal product of labor plus K into marginal product of K is equal to P. It means if all factors are paid according to the marginal product, then the total product is exhausted. Next is utility function. In order to know how partial derivative is used in utility function, let us consider an utility function. U is equal to x plus y into y plus 2. Now we need to find the marginal utility with respect to two goods x and y when y unit of x and phi unit of y are consumed. So the marginal utility with respect to s is the partial derivative of u with respect to x, that is y plus 2. For x is equal to 5, y is equal to 3, then mus is y plus 2, that is 3 plus 2 is equal to 5. Now marginal utility with respect to y is the partial derivative of u with respect to y, that is x plus 7. For s is equal to 5, y is equal to 3, then muy is equal to x plus 7, that is 5 plus 7 is equal to 2. That's about utility function. So far we have covered important portion of partial derivatives in economics and also about the partial derivatives. Hope everyone liked this video. If you like, please like this video and subscribe my channel. We will see next time with another topic. Thanks for watching.